this is problem number 2. Okay, so the question is, we need to get the V1, V2, V3 by using nodal approach. Right, just to look at the circuit first, and we'll go with the same common 4 steps. So, step number 1, we need to identify the node at which the voltage to be found. That actually directly they mentioned the problem itself. Okay, they mentioned like find out voltage V1, V2, V3, and that means this problem having actually 3 nodes at which we need to find out the voltage, right? And I'll choose the down node as a reference node. You know that we need to choose any one as a reference node, right? So let us choose the down node as a reference node and take 3 nodes, the node 1, node 2, and node 3. Okay, right? So see the number of nodes for which the voltage to be find actually 3 for this problem. And see here, in addition to the resistor, there is some components. So what is the name of this component? What is the name of this component? 5 ampere, 10 ampere.
Battery.
No, it is not battery. See, they mention like ampere. Battery means it is
Current
like, yeah, good. So see, remember this is battery, or we used to refer this as a voltage source, right? But this is actually, see, in last class you've seen the other source called current source, right? This is actually current source. So they mentioned the current value and also the direction. So this is current source. So this problem they mentioned the current source. Let's see how we can deal this problem. So I told here we're having totally 3 nodes for which we need to find out the voltage, and let us choose the down node as a reference node. And maybe already they label the voltages. It's better I'll take this is node number 1, and this is node number 2, and this is node number 3. So I'll redraw the circuit once again. So this is 5 ampere current source. Okay, this is current source. Remember, this is current source. So whatever the problem is solved up to now, we have solved only with the help of with the voltage sources. But here we're having a current source, right? And that is the reason why in last class I explained about current source, and also I explained how to convert voltage source to current source and vice versa. So generally, when you deal the problem using nodal, you can find the current sources also. 4 ohm, 10 ampere, 1 ohm, 1 ohm. Okay, right. So let us choose. This is node number 1. This is node number 2, and this is node number 3. Okay, and this one I'll choose as a normal ground node, right? 0 potential. And let us make the voltage at node 1 as V1. That already mentioned the problem. I'll take the same voltage at node 2 as V2, and voltage at node 3 as V3, right? Next step 3, we need to apply Kirchhoff current law to all the 3 nodes. So let us apply Kirchhoff current law first for node number 1. Listen carefully how I am going to apply the KCL at node 1. Apply KCL at node 1. Okay. Right. See here, node 1 is this one, right? This is node 1. And you know that as per Kirchhoff current law, we need to put like the sum of incoming current equal to sum of outgoing current, right? I repeat, sum of incoming current equal to sum of outgoing current. For that, first you figure out how many components, right? How many components are connected to the node number 1. Tell me how many components are connected to node number 1. How many elements are connected to node number 1?
3, sir.
3, right? 1 ohm, 1 ohm, 2 1 ohm resistor, and 1 5 ampere current source. Okay, so better I put that same here so that you'll be easy to apply. And this is actually connected to node 3. Okay, this one more and this one more, and again there is a 5 ampere current source. Okay, this is actually 5 ampere current source. So this is actually current source. So straight away we can take this current and see this current actually incoming, right? And as I told already, the remaining current will always assume outgoing currents. Okay, so let us take the current through I1, sorry, current through 1 ohm as I1 and current through the upper 1 ohm. This is as I2. Okay, and I assume both the current are outgoing current. Okay, again I'm telling it just assumption only, right? I assume the current which is coming out from the node 1 are outgoing currents. And if 3 elements are there, you put 3 current. Okay, so only 2 elements which is connected, only 2 resistors which is connected at node number 1. So for that I am taking I1 and I2. Now we can apply Kirchhoff current law. Now as per Kirchhoff current law, the incoming current equal to outgoing current. See here, incoming current is 5 ampere current. They directly mention the current source value, right? 5 ampere. So incoming current 5, outgoing current I1 plus I2. See, this problem is somewhat different from the problem which you saw last class. Last class problem, they given the voltage source. Okay, so voltage source means what we did is we actually try to find out the potential difference between the 2 points and we put like the divider by its resistance. But here they directly given the current source, so I can directly take the current value as 5, right? And this is actually incoming as per the direction they mentioned. This is the incoming current. I told last class also, if they mention the direction of current, you go with that, right? They given clockwise, you take clockwise. If they given anti-clockwise, you better choose anti-clockwise. But there is no wrong even if you assume always all the currents are outgoing current. You can, yes, you can assume this current is also outgoing current. If you assume this current outgoing current, then you need to take this as a -5 because both are opposite to each other, right? You assume direction is straight opposite to whatever the direction they mentioned. So both are opposite to each other. In that case, you must take this as a -5. Okay, so better you don't change if they mention the direction in the problem itself. So 5 ampere it is incoming and I1, I2 are outgoing. Now let us try to figure out I1 and I2. You know, as per Ohm's law, I equal to V by R, right? So I'll go with the same approach now. Now tell me I1 is actually current through this 1 ohm resistor, right? Tell me what is I1? Anyone, what is I1? Same approach which you see in last class. What is I1 current?
V1 minus V2 by 1 plus V1 minus V3 by 1 equal to 5.
Yes, perfect. Good. See, this 1 ohm, this I1 is current through this 1 ohm, which is connected between node 1 to node 2. So we can keep V1 minus V2 divided by 1 plus I2. I2 is current through this upper 1 ohm, which is connected between node 1 to node 3, right? Then it has to be V1 minus V3 divided by 1. Okay, V1 minus V3 divided by 1, which is equal to 5. Now we just simplify this expression. All are 1, right? So V1, V1, 2V1 minus V2 minus V3, which is equal to 5. Okay, this is equation number 1. Right? Clear on this one? Clear, yeah? We'll go for next. Yeah. Next, let us apply KCL at node number 2. Okay. So again, if you take node number 2, actually node number 2 connecting 3 elements, right? 2 1 ohm resistor and 1 4 ohm resistor. Better I draw that here so that you can easily apply the Kirchhoff current law. So this is node number 2, which connects 1 ohm, here node 3, and this side again 1 ohm. This is node 1 and middle 4 ohm, which is connected to 0 potential ground. Okay, this is actually ground, right? And this voltage is 0. Right? This is 4 ohm, this is 1 ohm, and this is 1. Okay. Now you assume there are 3 elements, no? So all must have a different current, obviously. So let us take the current through this I4 as I3 current. and let's take this current as I4. I'm assuming all the currents are outgoing currents, and this current is I5. Okay, I3, I4, I4. Now we can easily apply Kirchhoff current law. So as per Kirchhoff current law now, I4 plus I5 plus I6 equal to 0. Okay, now we'll apply one by one. Let us try to get first I4. I3, yeah, okay, sorry. I3, I4, I5. I3, I4, I5. Let us try to figure out first I3. See, I3 is the current through 4 ohm resistor, which is connected between node 2 to the node at which the voltage is 0. That is ground node, right? So we can take now I3 as node 2 voltage unknown, that is V2, right? So V2 minus 0, okay, minus 0 divided by 4 plus I4 is current through this 1 ohm resistor, which is connected between node 2 to node 1. Now for this case, the voltage, the current through the this 1 ohm resistor is V2 minus V1 divided by 1, right? V2 minus V1 divided by 1. Then next I5. I5 is current through this 1 ohm resistor, which is connected between node 2 to node 3, right? So we can keep plus V2 minus V3 divided by again 1, okay, which is equal to 0. Now again you simplify this expression and write in terms of V1, V2, V3. So now V1 minus V1, right? Only one V1 term is there, so minus V1. V1 by 1 is V1, right? So I'm putting directly minus V1. Then V2, there are 3 V2 terms are there. V2 plus V2, 2 V2 plus 1 by 4 V2. 1 by 4 means 0.25, right? So it is going to be 2.25 V2. Okay, and again it is plus, right? Plus 2.25 V2. So I'm directly simplifying, just I'm making mathematical simplification. Right? 2.25 V2. Right? Then about V3. V3 we having only one term, right? So minus V3, right? Minus V3 equal to 0. Right? This is equation number 2. Clear, Ra? This one is clear? Okay, done. Similarly, we'll try to apply KCL at node 3 now. Now apply KCL. And again in node 3, there are 3 elements are connected. 2 1 ohm resistor and 1 10 ampere current. So better I draw the circuit once again here. This is actually connected between node 3 and node 1, right? 1 more. Then additionally 1 more 1 ohm resistor. This is node 2, and again this is 1 more. Then also 10 ampere 10 ampere current source. Okay, this is 10 ampere current source, right? And this is the node 3 elements. Now let us apply Kirchhoff current law. Okay, let us take again, this is directly current source, so we can directly take this as an incoming current. Just look at the direction, it is incoming current. And for remaining 2 elements, I'll assume outgoing currents, these 2. Okay, and let us choose this is I6 current and this is I7 current. Okay, because we already taken up to I5, so I'm going with I6, I7, right? I6 current and I7 current. Right, now let us apply KCL here. Now as per KCL, incoming current equal to outgoing current. Incoming current 10. Okay, 10 ampere, just look at the direction. 10 ampere current is incoming, right? Then there are 2 outgoing current, I6, I7, I6 plus I7. Now you expand, right? You try to get I6 answer and also I7 answer. I6 is actually current to this one node, which is connected between node 3 to node 2. So it must be V3 minus V2 divided by 1 plus I7, which is connected, that is I7 is current through 1 ohm, which is connected between node 3 to node 1. So we can keep V3 minus V1 again divided by 1. Okay, now you simplify this expression, you write in terms of V1, V2, V3. V1 minus V1, only one V1 term is there, but against only one V2 term, so minus V2. And V3 term, there are two V3 term, V3 plus V3 plus 2 V3. Okay, 2 V3, which is equal to 10. So this is equation number 3, right? So these are all the 3 equations, which is derived from by applying the Kirchhoff's current law at node 1, node 2, node 3 respectively, right? Now, step 4, we need to apply the grammar rule to find the solution, right? V1, V2, V3. So that we did multiple times. So I'll straight away give the answers. You all please try and verify this. Step 4, so solve the equation. So I'm not going to solve it. I'm straight away giving all the answers because you solve many problems. How to get del I1, del V1, del V2, del V3. Okay. The answer for del. First, I'll write the formula. As per grammar rule formula, it is actually V1 is actually del V1 by del, and V2 del V2 by del, V3 del V3 by del. Okay. So I just give the final answer. You please note down and also you try and verify. So the answer for del approximately 0.75. Answer for del V1 50. Answer for del V2 45. Answer for del V3 51.25. Okay, and the final answers V1 66.66 volt. It is 66 closer is going to be correct. Aravind Kumar 66.8. Okay, but you said just minus verified. I think it is going to be plus 1. 66.66 volt or something. 66.6 or 78 is correct. Then V2, yes, V2 60 volt. Good. Then finally V3, yeah, 68. Yes, 68.2 or 3 or 4. Okay, 68.23. Sorry, 68.33 volt. Okay, this is the answer. Okay, you please all note down and also leave some space in class note. Later on, you do it and verify. I don't want to waste the time because we solved many things already the same way. So better we move on to the next problem. You please note down the answer now and also leave some space. Maybe later on, you just check all these answers. We'll move on to the next problem. Any doubt in this problem? Shall we move on to the next one? Ravind, okay, Ravind, thank you. Good. Any doubt? Shall we move on to the one more problem? Okay. Copy this and also note down all the answers and also leave some space. Okay, in the past note. Later on, you do it and verify all these answers. Okay. Copy it. So we'll go for next one. Okay, copy the problem.
Yes, sir.
Right. Maybe I'll take up one more problem in order. Now the next problem. Determine the voltage. Determine the voltage at each node for the given circuit and also find current through 5 ohm resistor. Also find current through 5 ohm resistor. Note on the circuit. This is the given circuit. The voltage 10 volt. Actually, here they also mention current source. Sorry. This is 5 ampere. This one 5 ohm. This is 10 ohm. This is 3 ohm. This is 3 ohm. This is 2 ohm. This one 1 ohm. This one 6 ohm. Okay, this is the given circuit. Now see this. See the first problem. If you see that in nodal, we have taken circuit only with voltage source. And second problem, we have taken the problem only with current source. But here, if you see, we have both voltage source and current source. Okay, so let's see how we can deal this problem. See, whatever may be the source they given, don't worry. We just apply whatever the concept you learn. Just to choose the node, and that for that node, you just apply the Kirchhoff current law. If it is a battery, you try to apply this the normal approach, right? If it is a current source, you take the current value directly, and whatever the direction they mention in the current source, you take as it is. If it is an incoming current, you take as incoming current. If the current is like outgoing one, you take as outgoing. Okay. Let us see how we can solve this problem. Right. First, you need to identify the number of nodes, right? Tell me here how many nodes are there for which the voltage to be defined. How many nodes?
5 unknown nodes, sir.
How many? How many nodes are there?
5.
2. Only 2. Just check once. Only 2 or 3. Actually, this. Anyone? Any answer? How many nodes are there?
What, sir?
Total 8 nodes, right? Okay. Total 8 nodes, right? Let's see. So obviously this is node, right? Because it is connecting two components, like 10 volt and 10 node, and this also node number 2, and this also node number 3, and this also node. This also this we can't claim as a node because it is not connecting anything, right? It is, see, it is all our common point. All are common point which is connected to the ground terminal. So this can also be node. So I can take this as A, let's say example A, B, C, and D, and this is G. So totally this problem having 5 nodes. Yes, good. Someone answered correctly. Venkateswara Reddy, very good. Yes, this problem having totally 5 nodes A, B, C, D, E, in which the node A voltage already known, right? Because it is directly connected to the 10 volt battery. So voltage at node A is actually 10 volt, right? And node B voltage unknown, node C voltage unknown, node D voltage unknown, node E voltage because it is ground, it is 0, right? We already seen we have to choose one node as a reference. In the problem itself, they mentioned this node as a reference node, right? So you know that reference node means its voltage is 0. So voltage at node E also 0 now, right? Voltage at node E is actually 0. Now the only thing we need to find out voltage at node B, node C, and node D. That means that only there are 3 nodes for which the voltage to be found. Okay, node B, node C, and node D. Right? Let us choose this node B as node number 1, and C as I am putting in the problem itself. You better draw once again. You mark it. Okay, and this as node 2, and this is node 3. And let us choose the voltage at node 1 as B1, right? And voltage at node 2 as B2, and voltage at node 3 as B3. So the question is, they asked to find out voltage at all the nodes, right? And now we found a node at 2, that voltage at 2 nodes. Based on the circuit, we identified the voltage at node A as 10 volt and node E as that is voltage at node E as 0 volt. The only thing we are going to find out the voltage at DCD, that is node 1, node 2, and node 3. Okay, the same approach. Now let us apply first Kirchhoff current law at node number 1. Okay, apply KCL. Apply KCL at node number 1. See, first node number 1 actually connecting how many elements? 1, 2, 3, 4 resistor, right? 2 3 ohm resistor, 1 10 ohm resistor, 1 5 ohm resistor. So it is connecting totally 4 elements. Maybe I'll put it here. So this is node 1, and this is 3 ohm. Let us take this is 3 ohm, which is connected to node 2. And similarly, one more 3 ohm resistor connected to node 1, right? One more 3 ohm is connected to node 1. Then there is 10 ohm resistor which is connected between node 1 to this node. This node is A. Okay, and again we having a one more component here. This is 5 ohm, right? This is 5 ohm, okay, which is connected to zero potential node. This node voltage is 0 volt, right? This is node 1, right? Now as usual we choose here all the currents are outgoing currents. Let us take the current through 5 ohm. I'll choose current through 5 ohm as I1, this is I2, and this is I3, and this is I4. Okay, right? Now let us apply KCL. So as per KCL, you know that incoming current, sum of incoming current equal to sum of outgoing current. So we assume all the currents are outgoing, so I'll go with that. I1 plus I2 plus I3 plus I4, which is equal to 0. Now let us try to figure out one by one. I1 is actually current through 5 ohm resistor, right? Which is connected between node 1 to 0 volt node. You know, node 1 voltage unknown, right? So we already chosen node 1 voltage is V1 minus here the ground node voltage is 0 volt, right? V1 minus 0 divided by resistance 5, right? Plus I2. I2 is current through 5 ohm resistor, which is connected between node 1 to node A. Node 1 voltage V1. What is node A voltage? What is node A voltage?
10, sir.
10. Yes, node A voltage as per the circuit, the node A voltage is 10. So it is going to be V1 minus 10 divided by the resistance 10, right? Then plus I3. I3 is current through this 3 ohm, which is connected between node 1 to node 2. Actually, both 3 ohms are connected between node 1 to node 2. So we can simply keep V1 minus V2 divided by 3 for the first resistor, first 3 ohm resistor. Then again we have one more 3 ohm resistor. So plus V1 minus again V1 minus V2 divided by 3. Okay, which is equal to 0. Right now you just simplify everything and you try to write in terms of V1, V2, V3. First V1 V1 by 5 plus V1 by 10 plus V1 by 3 plus V1 by 3. So 1 by 5 plus 1 by 10 plus 1 by 3 plus 1 by 3. You add it everything. Tell me 1 by 5. 1 by 5 plus 1 by 10 plus 1 by 3 plus 1 by 3, right? 1 by 3 plus 1 by 3. So I think 0.966 plus 0.966 will get. Okay, so we'll put 0.966. See, I'm writing in a single time, right? If you are getting confused, you simplify one by one and write it. 0.966 V1. Then I'll try to get V2 term. V2, there are two V2, right? 1 by 3 plus 1 by 3. That is minus 1 by 3 minus 1 by 3, right? So minus 1 by 3, 1 by 3, 1 by 3 means 0.33. Then again 1 by 3, 0.33. If you sum up both, you get 0.66. So minus 0.666, right? 666 V2. Then next V3, here there is no V3 term, right? There is no V3 term. So better we'll keep 0 V3. Okay, no V3 term. So for that I'm putting 0 V3, 0 times of V3. Now, right, which is equal to, we have a constant term here, right? So the constant term is 10 by 10. This 10 by 10 minus 10 by 10. You know, 10 by 10 means it is 1, right? Minus 1. When I move that onto the RHS side, you get plus 1. So this is equation number 1. So equation number 1, 0.966 V1 minus 0.666 V2 plus 0 V3 equal to plus equation number 1. Clear on this one? Okay, clear this one? Any doubt? Okay, done. Thank you. Next, let us apply KCL at node 2. Okay, so I'll apply for node 2 and listen carefully. Node 3 you are only going to apply. Apply KCL at node 2. And if you see the node 2, actually node 2 we having a current source also. Listen carefully. node 2 actually having totally 3 resistor and 1 current source, right? 3 resistor means 3 ohm resistor, 1 2 ohm resistor, and additionally it also having a 5 ampere current source. Okay, so better I put it here once again. So this is 2 ohm, which is connected to node 3, and then there are 2 3 ohm resistor. So this is node 2, right? And both are connected to node 1 only, right? And here there is a 5 ampere current source. Okay, this is actually node 2 components. Right now, just take this is actually given as 5 ampere. Now let us assume that the current through this 3 ohm, this is 3 ohm, right? There are 2, 3. Okay, let us choose the current through this 3 ohm as I5 and this is I6. Okay, I5, I6, and this one I choose it as I7. Right, I5, I6, I7. Right now, if you see that here, the 5 ampere is a current source, right? And it is actually incoming to the node 2. So incoming current is 5 ampere. Outgoing currents are I4, I5, I6, and I7. So I'm applying KCL again here. So as per KCL, the incoming current 5 equal to the summation of outgoing currents. I5 plus I6 plus I7. Okay, incoming current equal to outgoing current. I'm not change the direction of the current source, given current source direction. I told already, whenever the current source given with the direction, you don't change it, you take as it is. Okay, so this 5 ampere is incoming, so I'll put incoming current which is equal to outgoing current. Now let us try to figure out I5, I6, and I7. Okay, first I5. See, I5 is the resistor, that is current through the 3 ohm resistor, which is connected between node 2 to node 1. And the same for I6, right? So that means now the current through the 3 ohm actually equal to the voltage at node 2 and voltage at node 1 minus voltage at node 1. So you know that both voltages are unknown now, right? So it must be V2 minus V1 divided by 3. The same for I6, V2 minus V1 divided by 3, right? Then I7 actually current through 2 ohm resistor, which is connected between node 2 to node 3, right? And both voltages are unknown. Now the voltage across this 2 ohm resistor V2 minus V3, right? V2 minus V3, and if you want to find out the current, you must divide that voltage by resistance. Resistance 2, okay, which is equal to 5. Right now, you just simplify this expression and you verify the answer. V1 7.6, V2 19, V3. No, Aravind, somewhat slight deviation. You check once. Okay, now we'll try to simplify this expression. Now, first I'll try to figure out V1 terms. V1 term, there are 2 V1 terms, right? 1 by 3 minus 1 by 3 minus 1 by 3. So obviously it is going to be minus 0.666 V1, right? 1 by 3, 1 by 3, right? Then V2 term, there are 2 V2 term, right? 1 by 3, 3 V2 term, 1 by 3 plus 1 by 3 plus 1 by 2, right? 1 by 3, 1 by 3, 0.66, 1 by 2, 0.5, right? So 0.5 plus 0.66, you'll get 1.66, right? So plus 1.166, right? That is 0.666 plus 0.5. So you'll get 1.166. See, I'm doing simplification straight away, just a mathematical simplification only. Use calculator, otherwise you simply find 1 by 3 plus 1 by 3 plus 1 by 2, you'll get 1.166 V2. Right, then V3 only one term, so minus V3, it is minus 1 by 2, 0.5, right? Minus 0.5 V3, okay, which is equal to constant term 5. Okay, this is equation number 2. right? This is the equation number 2. Now, likewise, you apply KCL at node 3. Okay, I'll give the pharma straight away. That is answer straight away. You all try by yourself and verify. KCL at node 3. Right. So the answer is, after you apply the KCL, you get this equation. You please verify 0 V1 minus 0.5 V2. I'm writing final answer to apply the method, the procedure which we discussed before, and try to verify it. Minus 0.5 V2 plus 1.666. Okay, 1.666 V3 equal to 0. V2, right? Okay, V2. Okay, Aravind, your answers are closest to the actual answer. Maybe you've taken only 2 digits. That's why you get this answer. But it is correct only, no problem.
Okay, sir. Thank you.
Right. And then you need to solve this 3 equation. I'll give the answer, and you apply the same grammar rule method and try to verify it. So the thing is that if you taken 2 digit, you will have some slight variation answer. Okay. So better you, what I suggest, you better always go with a 3 digit. After the point, you take 3 digit so that you can get accurate. So I'll write first step 4. I need to solve the equation. So I'll write for del answer. The answer for del 0.9. Answer for del B1 7.23. Answer for del B2 9.14. Answer for del B3 2.748. 2.748. Okay, then final answer B1 8.03, approximately nearer to 8 is correct, 8.03 volt. V2 10.15 volt. V3 3.05 volt. Okay, 3.05 volt. Anything closer, as much as closer is correct only. It is depends on how much digit you have taken after the point. Okay, this is the node voltages. But in the question, in addition to that, they also ask to find current through 5 ohm resistor, right? So let us see how we can find out the current through 5 ohm. Listen carefully. Say 5 ohm is actually the resistor which is connected at node number 1, right? Okay, this is the 5 ohm which is connected node number 1, and we already assumed that the current through 5 ohm is I1 current, right? And for that we already written the formula. Okay, I'll use the same formula here. So the current through 5 ohm actually equal to current through 5 ohm actually equal to, actually this is connected between node 1 to node E, right? Node E voltage is already 0, so it is going to be V1 minus 0 divided by 5, right? So V1 we already found, right? V1 actually 8.03 divided by 8.03, right? 8.03 divided by 5. Okay, this is the answer. So 8.03 divided by 5 is 1.6 ampere. 1.606 ampere. So current through 5 ohm